Our modern world is pretty much built on digital connectivity, right? Everything from our banking to our healthcare, pretty much all the essential services we rely on, they all depend on the internet. But what if that whole foundation just vanished, even for just one day?
So that's the big question we're tackling. What would really, truly happen if the internet went dark for a full 24 hours? The effects, as you'll see, are probably a lot more profound and far-reaching than you might think.
So here's how we're going to break it down. First, we'll define what an internet outage actually is. Then, we'll look at the immediate consequences. And after that, the cascading domino effect. We'll also explore why these outages happen and finish up by looking at how we might build more resilient networks for the future.
All right, first things first. Let's get a handle on what we even mean by an internet outage. It's not as simple as someone flipping a giant off switch for the whole world. You see, the internet's greatest strength is that it's decentralized. There's no one single computer to just unplug. It's this massive, sprawling web of physical hardware, cables, computers, servers, all connected across the globe. Now, this means a total worldwide shutdown is highly unlikely. But could we have widespread, catastrophic disruptions? Absolutely. And here's a real-world example from Arizona that shows you just how vulnerable it can be. A single fiber optic cable was deliberately cut, and just like that, it severed communications for a huge area. Debit cards stopped working, cell phones went dead, and even 911 services were crippled. It's a perfect illustration of how one local event can have massive consequences. So, if a large-scale outage like that were to happen, what breaks first? Let's move on to the immediate consequences and see which services we all depend on would fail in an instant. Within moments, the core functions of our society would just grind to a halt. Emergency services would lose their main communication lines. Financial transactions would freeze. Your credit cards, the ATMs, they'd all be useless. And most phone calls, whether on cell or a landline, actually rely on internet infrastructure, so they'd be gone too. Hospitals, transportation systems, even paying for gas, it would all go dark. This isn't just a theory. This is what's at stake. During an outage in 2019, this hospital in Phoenix completely lost access to all its patient records. Lab work, radiology studies, medical histories, all suddenly unavailable. Now, luckily, no patients were harmed in that case, but it really highlights a critical dependency in our healthcare system.
But the impact doesn't stop there with those immediate failures. The real danger, the one we really have to worry about, is the domino effect. This is where the failure of one system starts to trigger failures in others. It's something called a cascading failure.
Basically, a cascading failure is a chain reaction. Our modern infrastructure networks aren't independent anymore. They're all deeply interconnected. So a single point of failure can spread through all these connections, and that can lead to a total system-wide collapse. And you can see how this would play out, right? For example, say the power grid fails, and more of it relies on smart technology. Well, that could immediately take down our communication networks. Without communications, our transportation systems can't coordinate. And with no power, no communication, and no transport, the financial system is completely paralyzed. Each system depends on the others to function. And again, this isn't just some abstract model. Our most vital services, the ones that ensure we have clean drinking water, that manage the flow of electricity, and that deliver our goods, are now run by internet-connected systems. Their interdependency makes things really efficient, but it's also a profound vulnerability.
So we've seen the effects, but what actually causes these outages to happen in the first place? Let's take a look at the primary sources of these disturbances.
You can pretty much break down the causes into four main categories. First, you have physical damage, like that cut fiber optic cable we talked about. Second, there are software bugs, a faulty update that crashes everything. Third, you've got deliberate cyber attacks. And finally, you have politically motivated shutdowns where governments themselves intentionally cut off access. And that last one is becoming a bigger and bigger issue. This data from the Brookings Institution shows a really clear and rising trend of governments deliberately interfering with internet services. It's being used more and more as a tool to control information or suppress dissent. Beyond the social impact, the economic cost is just staggering. According to one study, internet shutdowns cost the global economy at least $2.4 billion in a single year. That number represents lost e-commerce, stalled business operations, basically the entire digital economy just grinding to a halt. So, given these vulnerabilities and the incredibly high costs of failure, how do we build a more robust and resilient digital world? Let's turn our attention to some potential solutions.
The fundamental problem here is our over-reliance on just a single type of infrastructure. When everything from emergency services to the power grid depends on the exact same networks, well, we create a massive single point of failure.
One really forward-thinking solution is what's known as the MARS concept. Think of it as a strategic framework for designing our communication infrastructure so that it avoids those single points of failure. Let's break down what each of those letters means.
Okay, so MARS stands for multi-layered, which means combining different networks like ground-based fiber and satellite systems. Anywhere, using those satellites to get 100% coverage. Resilient, and this is the key part, because if one layer fails, another can take over. No single point of failure. And finally, sustainable, making sure it's optimized for both cost and energy.
The key to this whole multi-layered approach is having a reliable backup. And this is where satellite technology becomes absolutely crucial. When our ground networks are damaged, say by a natural disaster or a physical attack, satellite systems can provide a totally independent alternative pathway for our most critical communications.
And all of this brings us to our final question. We have built an incredibly efficient world that runs on a single interconnected network. But, as we've seen, that efficiency comes with a whole lot of fragility. So is it time we start seriously investing in a robust, multi-layered backup to protect the essential services that underpin our daily lives?